Thank you. Good morning, everyone, and good evening for Dr. Xu. Yes, and thank you. Welcome to the fifth international seminar on climate change mitigation, and thank you very much for joining us today. My name is Xiaofang Zhang from Chiba University, and I will be your moderator for this session. And before we begin the main program, I would like to invite Professor Jiro Mizushima, the head of our research group on fairness and social justice, to deliver a few opening remarks. And Professor Mizushima, thank you for your being here today. The floor is yours.
Oh, do you hear me?
Yes.
Thank you. Hello, my name is Jiro Mizushima. I'm a political scientist and now I'm teaching at Chiba University. And at the same time, I'm the director of the research program of Chiba Studies on Global Fair Society. So our common theme is a fair society. Today, thank you for joining our online seminar, everybody. And now we are very happy that we have a special guest from United States, Professor Su, who will kindly speak about climate change and racial social disparity. The main theme of our research program is at this university is fairness, and therefore it is, I think, extremely important for us to look at the impact of climate change on the social disparity. Climate change is, of course, one of the most important factors which widens the gap between classes and races and aggravating social unfairness. From that perspective, today's topic is quite insightful, highlighting the effect of heat island in urban areas, and it will contribute to the debate about the fair society. How can we achieve fair urban society? And now, as you know, it's September. According to the calendar, we are in the autumn. However, I don't believe, or I can't believe that it's autumn. The maximum temperature is well above 30 degrees, and it seems that summer is continuing forever. This fact shows the importance of today's topic. With a solution of climate change, we have no autumn, we have no future. I believe that we have to take back autumn, the most beautiful season of the year in Japan. I believe that this online seminar would make a great contribution to understanding of climate change, public policy, and the vision of fair society, and we will promote our international research cooperation tackling the global acute problems. Thank you.
Thank you very much, Professor Mizushima. Now, let me briefly introduce today's speaker, Professor Andrew Xu. And Professor Andrew Xu is an associate professor at the University of North Carolina at Chapel Hill, and is widely known for her research on climate policy, urban sustainability, and environmental justice. Her work focuses on the use of data-driven approaches to advance equitable climate action, particularly in the cities and vulnerable communities. Today's talk is titled, Who Bears the Hit? Racial and Social Disparities in Urban Climate Risk. The presentation will last around 15 minutes to 1 hour. After the talk, we will first invite Professor Jiro Mizushima to share some comments as a discussant, and then proceed to the Q&A session with the audience. Please feel free to join or leave the session depending on your schedule, and you are welcome to post your question in the Zoom chat at any time. Now, Professor Xu, the floor is yours.
Thank you so much, Dr. Zhang, for the really kind introduction, and to Professor Mizushima for the really nice introduction to my work and to the topic of climate change. I completely agree with you that temperatures continue to rise, and year after year, we're feeling hotter summers on average. And I'm afraid to say that it's probably the new normal unless we drastically do something different on policy and in our everyday behaviors and also to reduce our emissions. So with that, I will share my screen and show my slides. Everything look okay, Dr. Zhang?
Yes, it's okay. I can see it
Okay,
clearly.
wonderful, wonderful. So I would be remiss as an IPCC scientist, so that's the Intergovernmental Panel on Climate Change, which is the international body where governments nominate different scientists to then synthesize the latest climate change science to provide guidance to policymakers in terms of what is the physical basis on climate change, how can societies adapt, and then what can we do to mitigate our impact and mitigate our emissions to try to avoid the most dangerous impacts of climate change. So I was lucky enough to be one of the contributing authors to the sixth assessment report on Working Group 3 on mitigation. And then I'm currently a lead author to the special report on cities and climate change in the seventh assessment cycle. And so I wanted to start with a conclusion from the sixth assessment report where I was quite shocked in following the IPCC and teaching its findings in my climate change class. I was really shocked that in the policy maker summary, it was this particular conclusion. It is indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall, and droughts more frequent and severe. So I like to start my class in my climate science and policy class with this particular headline statement because I think, first of all, the language is very strong. They say it's indisputable. And for scientists to make such a strong claim, they really have to be 100% certain or just about in order to make this kind of claim and to use such strong language of indisputable. And so we know that climate change is happening and that human activities are driving the increase in emissions and the increase in temperatures. And that's having impacts all around the world. And we can see that as temperatures are warming all across the world, that's coinciding with socio-demographic and population trends, including the increase of people moving to cities, cities themselves growing and becoming larger. And so on the left, you can see in this figure, also from the IPCC, that the urban population is growing and quite drastically. And so about 50% of the world's population is living in urban areas. And that number is expected to increase to about 68% by mid-century. At the same time, we're seeing that temperatures are increasing in these urban areas. And so in cities all across the world, including Tokyo and Beijing, New York City, you can see that the days when temperature and humidity conditions pose a risk to human health and can directly lead to increases in deaths as a result of heat exposure are expected to increase quite a lot at just 2 degrees Celsius warming above pre-industrial levels. And so that's quite alarming. And in this particular chapter and conclusion in the IPCC, the scientists further conclude that evidence from both urban and rural areas is unequivocal. Again, this very strong language, indisputable, unequivocal, that climate impacts are felt disproportionately in urban communities, in cities, with the most economically and socially marginalized being the most effective. So we're seeing the concurrent trends and this intersectionality between the most vulnerable population living disproportionately in cities, where temperatures are also increasing quite drastically as a result, as Professor Mizushima said, the result of the urban heat island effect. And we're seeing that those impacts are unequal. And so wealthier cities obviously have the ability to adapt. They can have air conditioning, they can live in buildings where there's constant cooling. They have personalized motorized transport to drive them from cool place to cool place. But we can see, particularly in areas of the global south, where those conditions are not as favorable and where there's not as much availability of air conditioning and cooling adaptations, and where you have people who spend more time outdoors, such as outdoor workers, agricultural communities that may face those temperatures and feel those impacts disproportionately. And I mentioned that all across the world, we're seeing temperatures rise year on year and become warmer on average. And so headlines such as these that I pulled from the internet are becoming a lot more common, where you're seeing record-breaking temperatures in US cities like Phoenix and Memphis and Houston. But then you're also seeing China, just a few years ago, battled its worst heat wave on record. they had temperatures over 40 degrees Celsius for more than 60 days and recorded record-breaking hottest temperatures in history on record ever. And even in Europe, you can see these maps of land surface temperature in France and in Spain. Regularly, they're having temperatures that reach as close as 55 degrees Celsius. And that's also causing a lot of economic disruption across the world as well, where you can see in agricultural supply chains, shortages in mustard in Canada and chili peppers, coffee, and wine. All of these food staples are having shortages as a result of the climate crisis. And a couple years ago, chip shortages were also a huge problem. And so people couldn't get consumer goods, like from vehicles to computers to anything really these days have computer chips. And that was because in China, where a lot of them are being manufactured, they were facing record temperatures that were leading to very low levels of water and shortages of hydroelectricity. And shipping also became a huge problem for the young people. So I like to show this slide to my students because they're huge fans of Taylor Swift, who is a mega superstar in the pop world. Actually, a couple years ago in Rio de Janeiro, a fan died because of record high temperatures, and she had to delay some of her concerts because of a heat wave that had struck Rio de Janeiro in Brazil. And so we can see from all of these different aspects in terms of our leisure activities or agricultural supply chains, economic productivity, heat waves are becoming the new normal and affecting everyday life. But those impacts are not being felt equally all around the world. So this photo is from Mexico City. There's a wonderful photographer, Johnny Miller, who has this project called Unequal Scenes, and he takes these aerial images from cities all across the world. And what really strikes me about this photo is you can see a much wealthier neighborhood with the trees and really nice sports facilities. You see these very nice houses in this residential community. That stands in direct contrast to this neighborhood on the left, which is characterized by informality. And you can see a lot of density in these houses that don't appear to be as regular and as consistent as these really nice suburban houses on the right. And what strikes me is this informal soccer pitch here that the residents living in this neighborhood have access to in direct comparison to these really nice sports facilities on the right. And of course, we're seeing these scenes of inequality all throughout the world. This is Johannesburg, where you can see this informal settlement on the left in the lower left-hand corner, and that's in direct contrast to this golf course and this very nice community on the right. In the United States, we see these images very frequently. This is Los Angeles, the downtown area, where you can see informal settlements and you can see encampments here on this major highway. And in the background, you see these skyscrapers. In Seattle, Washington, that's also a very common scene. You can see unhoused populations living underneath a busy highway. And of course, Seattle is well known in the United States for being a headquarters for Amazon and Microsoft. A lot of these wealthy tech companies that are driving housing prices very high in the United States. And so, one way to understand the inequality that's happening as a result of economic disparity and these economic trends, as well as the environmental consequences of this inequality, we have our project that's called the Urban Environment and Social Inclusion Index. So actually, this URL is a little bit out of date. We just recently updated the website. So the new website link is uesi.datadrivenlab.org. And this is a project where we have sought to use satellite remote sensing data to quantify and to be able to compare how cities all across the world are performing on Sustainable Development Goal 11, SDG 11, which sets a target for cities to be both inclusive and sustainable. But while the UN identified SDG 11 as a goal for all cities to strive towards, they didn't actually provide the data to develop in a spatially explicit way indicators for cities to know whether or not they're actually providing for social inclusion and equity and also preventing people from being exposed to environmental harms like air pollution, urban heat island in the same way. And so this is Los Angeles again, and you can see here on the left a map of income by neighborhood. The darkest green neighborhoods are those that are the wealthiest. So this is Santa Monica, and you can see that the income is on average over 90,000 US dollars per person. Is probably more because a lot of celebrities live in this neighborhood. This is actually one of the neighborhoods that was affected by the wildfires earlier in January of this year. And much less wealthy neighborhoods are here in blue, so around $30,000 per person on average. And that translates into real disparities when it comes to environmental outcomes. And so on the right, you see this is a map of tree cover percentage. So, how much of the neighborhood is covered by trees and canopy cover? And so, this wealthy neighborhood has the highest with over 70% tree cover. But then those less wealthy neighborhoods, this is Inglewood, for example, in this blue sliver. I don't know if you can see my cursor, but only around 5% tree cover in these less wealthy neighborhoods. And of course, that translates into all sorts of other disparities when it comes to environmental outcomes as well. And so on the next map, I have urban heat island, where you can see that the coolest neighborhoods are those that have the highest tree cover, so the greenest, and also happen to be the wealthiest, have the highest amount of income. Those neighborhoods that are the hottest are in red and this dark orange, and you can see that correlates with the least amount of tree cover and the lowest income. And so it's not just disparities in income that are affecting populations that live in these neighborhoods, but they're also at risk of higher heat related health effects and illnesses and heat related mortality. And trees are also known for filtering out harmful air pollutants. So you can also go on our website and look at neighborhood exposure to air pollutants like fine particulate pollution or PM 2.5 and NO2, and you'll see some of these same patterns. And when we talk about heat, the reason why we see these disparities in heat is due to the urban heat island effect. So the fact that cities are much hotter than their rural surroundings because of the fact that they have more asphalt and concrete and built materials. And so cities can be somewhere between 3 to 10 degrees Celsius hotter than a rural area. And that's because all of these materials, these man-made materials like concrete and asphalt, they can absorb a lot of the incoming solar radiation during the day and retain that heat to make cities, downtown areas, urban settings a lot more hotter than they would be otherwise. And so if we take a look at a signature of late afternoon temperatures and this red squiggly line, we can see that cities and urban areas are much hotter than, say, suburban residential areas or rural areas. So they tend to be much hotter in the late afternoon. And these patterns are common all throughout the world. And so in our Urban Environment and Social Inclusion Index, we have actually quantified the disparity of exposure to this urban heat island effect according to income. So you can think about a Gini index that measures inequality of income. And so the more unequally distributed this Gini index is, then that means that the richer have a higher concentration of income compared to poor populations. And so in this project, we adapted a similar Gini index, but for environmental indicators. And so this shows that those circles, those cities in red, they have a tendency to concentrate the urban heat island on poorer populations, so less wealthy populations. And so that's common all throughout the United States. So I'll dive into the United States in a little bit more detail. But even in Europe, parts of Latin America and the Caribbean, Sub-Saharan Africa, Southeast Asia, South Asia, Australia, they're all burdening less wealthy populations with a higher intensity of this urban heat island effect. In gray, those are actually the opposite. So these are cities where they're burdening wealthier populations with higher temperatures and with this greater intensity of the urban heat island effect. And so what's interesting, I always like to ask people, why do you think China has a lot of these gray circles? Some parts of Eastern Europe also have these gray circles. And it really points to the fact that in these cities, the underlying urban demographics of the population are quite different. So I lived in Beijing for quite a number of years. And I can tell you that Beijing, in the time that I was there from 2008 to 2013, underwent an incredible transformation where this was like a predominantly industrial city. You had a lot of agricultural populations moving in from neighboring provinces. But then very quickly, I was living in the central business district where they had Gucci's and they had Versace stores. And now Beijing has like 100 billionaires that are living in the city. And so that's one of the reasons why these circles are gray, because you have all of these wealthy populations that are living in these urban areas, and you still have a lot of rural areas surrounding these cities in China that still have a lot of grassland, that have a lot of forests, that make those areas a lot cooler. So that's one of the reasons for the differences in some of these cities. But overall, what we find is that the majority of cities all around the world are burdening less wealthy populations with higher temperatures. And in the US specifically, we can see not only is our cities burdening poor populations, so less wealthy populations with higher temperatures, but it also intersects with race and ethnicity. And if you're familiar at all with US history, after World War II, there was a systematic discriminatory set of policies that happened really at every level. So there were private covenants in neighborhoods and subdivisions that prevented certain minorities and low income populations from moving into these neighborhoods. You also had public de jure segregation. So you actually had laws at many different levels that enforced segregation, even when populations and communities wanted to integrate themselves. And you had this practice known as redlining. So you had the Homeowners Loan Corporation that developed these maps. You can see one of them in the background of this particular slide, where these were discriminatory practices that prevented low income and minority communities from accessing mortgages that would have allowed them to move into more desirable neighborhoods. And so they developed these maps. And so there were more than 200 cities all around the United States where the Homeowners Loan Corporation developed these maps. And you can see these D-graded neighborhoods in red were those that were less desirable. And so it was kind of a red flag for these financial institutions to avoid giving people who were from these neighborhoods those loans and mortgages to allow them to move into A or B neighborhoods that were a lot more desirable. And so Richard Rothstein has written this really incredible book. I would highly recommend you reading it, that goes into all of these different policies, both on the private and the public level, that actually reinforced segregation throughout American cities. Now, where I live in the Research Triangle area of North Carolina, so we are a constellation of cities. So I'm in the town of Chapel Hill, and we're next to the city of Durham, and that's right next to the city of Raleigh, which is the capital of North Carolina. And Durham was one of these cities that was historically redlined. So you can see here that in the blue areas, these were considered B, and then green, these were considered the most desirable or the best areas throughout the city of Durham. And you can see that a lot of these areas were actually red. They were redlined as being less desirable or hazardous was actually the designation. And that happened to coincide with racial demographics as well, where these red areas happen to comprise predominantly African American communities living within them. And so one of these neighborhoods in this D6 area here, I don't know if you can see where my cursor is. I actually have a map in the next slide. So this neighborhood in particular was known as the Hayti district or the Hayti community. And it was a historically Black community that was incredibly vibrant and was home to many Black families and Black-owned businesses. And in the 1960s, and this happened all throughout the United States, so between 1949 and 1973, the US government actually bulldozed around 25 neighborhoods in close to 1,000 cities through the brand of urban renewal. And so you can see one of the posters that was advertised in the Hayti community in Durham here in North Carolina, where they were talking about these plans for redeveloping the Hayti district to make it better and revitalized and more vibrant economically. And then there were these types of advertisements that went out to the community, and you can see, hello, we've waited a long time to get acquainted. And they talk about an effort to rid Durham of filth, rats, and ugliness. And that was very racially charged language at these communities. And so in the effort and under this brand of urban renewal to try to revitalize these slums and blight, they actually sought to evict around 95% of the families that lived in this Hayti district. And they actually got the Black vote. And so they essentially convinced the Black community to vote for urban renewal and these policies that effectively evicted them with no compensation. The only structure that remains in this once vibrant Black community is the St. Joseph's AME Church, where now they have the Hayti Heritage Center. And that's really the only relic of this community, this once vibrant Black community. And you can see in this map here from 1972 the effects of urban renewal, which is creating this really hideous Durham freeway known as Highway 147 that basically bisected and intersected and tore apart this vibrant Black community. And the legacy today, according to heat mapping that we did collaboratively with the city of Durham and some other community organizations, is here, this big red spot in the middle, which has left this community one of the hottest all throughout Durham because of, you can see these pictures that I've taken myself of what it looks like. This is the freeway. This is the Durham Freeway, Highway 147, not developed, not renewed, and not made vibrant. And you can see that on one side of the highway, so I'm taking this picture from one side of the highway. So I was at the Hayti Community Center on one side of the highway, and then you can see these gentrified housing developments that are popping up at rapid speed in Durham. And it really has left the community vastly underdeveloped. So you can kind of see the Durham Freeway above on the northern side of the highway. You can see there's a lot of development. There's a baseball stadium, but then really there's just this ugly parking lot. There's this it was called the Heritage Shopping Complex, and it was primarily Black-owned businesses. The last one was shuttered just a few years ago and is largely remain underdeveloped. And so this story happened, as I mentioned, in cities and neighborhoods all across the United States, where under the brand and the guise and the promise of urban renewal, Black and minority communities were basically pushed out of their homes and not compensated. And the result in the United States has been that in these formerly red line zones that had people that were graded D, so these were hazardous community, even today, they are still predominantly non-Hispanic white residents that are living in these hazardous areas within cities all across the United States. And the best areas you can see on this map on the right are still occupied by white residents and wealthier residents living in them. And there have been lots of other studies and scholars in the United States studying from an environmental justice perspective exactly what the legacy of these redlining and discriminatory policies, these enforced segregation policies have meant in terms of environmental exposure. So this is from a well-known study by colleagues at Berkeley and University of Washington. And you can see that these redlining policies have meant that 45 million Americans are breathing dirtier air 50 years after these discriminatory policies were actually dismantled. So in major cities like Philadelphia, Chicago, Los Angeles, and Detroit, you can see that people living in those hazardous areas, so those degraded areas, are still exposed to much higher levels of air pollution than those living in those green and blue areas, so those A and B areas. And so, given this context, a lot of my work in trying to understand the legacy of these discriminatory policies has been whether or not to understand people who have lived in these red line areas or those who are economically disadvantaged or people of color are still being exposed to higher levels of urban heat compared to counterparts living in these more desirable areas or who are wealthier or also happen to be white. And so I have a project right now being funded by the NASA, so the National Aeronautic and Space Administration, and we have three main objectives in this project. First of all, can we identify where and how heat stress disparities exist and have changed over time, also as a result of these discriminatory and segregationist policies? Secondly, in the near term, can we try to understand what can cities do? So what kinds of policies can they implement? Is it tree planting? Can they try to manage albedo or the surface reflectance, try to make the cities more reflectant? So how can they actually reduce or manage heat stress through urban planning and policy measures? And then, because we know that climate change will continue to happen, can we utilize some of these projections to examine how disparities may worsen and where over time and for whom? And also, what may be the impact of mitigation measures to compensate for some of this background climate warming? So I'll talk first about the past and the present and what we're doing to try to answer these questions about how patterns of disproportionate exposure may have changed over time. And in order to do that, and because it's a project funded by NASA, and of course, NASA has launched all of these incredible Earth observation satellites where we can get consistent data over time, even historic data from the 1970s, to then look at how these patterns of exposure have changed over time. we have been focusing our efforts on using satellite remote sensing data to develop higher resolution models to be able to measure heat stress within cities and how they differ according to different populations and neighborhoods. And part of the reason and motivation for wanting to use satellite data is because I don't know how it is in Japan, but at least in the United States, many cities only have one weather station to actually get temperature and humidity and heat stress data. And so for North Carolina, you can see on this map on the right from the official National Weather Service, Chapel Hill, where I live, only has one weather station, and that's located at the airport. And so when I pick up my phone and I were to then go to my weather app and try to see what the temperature is for that day, it's likely pulling information from that single weather station at the airport. And of course, we know that people don't really live at the airport. They actually live in a urban area where there can be exposure to many different microclimates and different weather and climatic factors during the day, or they may experience different types of land cover or built environments that could also expose them to different temperatures and different levels of heat stress. And so that's one of the reasons why, if we use satellite remote sensing, we essentially get continuous, or how we say wall to wall coverage of measurements, because satellites are orbiting the Earth every single day. And so we can actually then compare the land surface temperature over a particular urban area and compare it to a rural area, subtract that difference. So that's this SUHI measure. So we can subtract the temperature measured by satellites over a rural area from the temperature measured by satellites over an urban area and get a consistent measure all across the world of this urban heat island intensity. And that's exactly what we did. And so we have this Google Earth Engine Explorer app. You can check it out here in this URL link. And my colleague who we work with and collaborate with, TC Chakraborty, he's at the Pacific Northwest National Lab. He actually has this data for the entire world. But for this particular project, we wanted to look at the intersection of this urban heat island disparity with socio-demographic and economic factors as well, to understand who in the United States is being exposed to what levels of this urban heat island intensity. What income levels are they? What race? What age? So we wanted to be able to examine these questions by merging together these different data sets. So you can explore all of these trends for all nearly 500 urbanized areas in the United States. And so we took this data to answer this fundamental question of, do we see disparities in urban heat island and temperature exposure in some cities in the United States, or are they cities that were just redlined, or is this a broader problem that's indicative of something deeper and more systemic going on? So we did the first large-scale study, and this study was published in Nature Communications a couple years ago, and you can see pretty striking patterns and differences. And so when we compare different groups of people and their exposure to urban heat island, we see some pretty stark disparities. So in most major US cities, so I say major US cities because these are cities with a population greater than 250,000, but of course we see some of the same disparities in smaller cities as well. We just wanted to have a more coherent story and just look at the top major cities. But you can see in this red density curve here that on average, people who are people of color, communities of color, are exposed to much higher on average surface urban heat island compared to their non-Hispanic white counterparts. And actually, the patterns look very similar when you consider people who are living below poverty. Those patterns are virtually the same. When we talk about age, we can see actually that compared to people who are under or over 65, the distribution is about the same. But then when you factor in age and race, you see the same patterns in panels G and H as you do in panels A and B, where people of color who are over 65 tend to be exposed to much higher temperatures than people who are over 65 and white. And then same thing for under 5, all people of color are exposed to much higher temperatures and surface urban heat island intensity than white populations under 5. So this was quite surprising to me. I thought maybe just in redline cities, perhaps just in major cities like Boston, Philadelphia, Atlanta, New York, we would see these patterns, but it was pretty universal. So in 97% of major US cities, minority populations are exposed to higher urban heat island intensity. And so it was just really in a few cities. So I'm trying to circle these circle points. So one is in McNally, Texas, where there really weren't high minority populations that were non-Hispanic minority populations living in that particular city. So a few in Texas, one in California. So not that many. There were really just 6 cities where we saw this pattern reversed. And in particular, the differences, so the triangles are much bigger in terms of much starker differences, much worse actually in the Northeast, where I lived for 10 years in the United States. And so that was surprising. I thought that the disparities would be more intense in hotter areas and arid climates such as the Southwest US, or even in the tropical climates, like, for example, in Florida. But we actually saw the greatest disparities in the Northeast. And that was also true for when we looked at income and populations below poverty compared to those that were living above poverty. So the same patterns. And again, most intense disparities in the Northeast. So also people, if you're poor, then you also happen to be exposed to higher levels of urban heat compared to your much wealthier counterparts. And what's interesting in the United States is that these populations of minority communities and those living below poverty do not 100% coincide. So there's only fewer, I think less than, I can't remember the exact number we said in the paper, but I think fewer than, yeah, like a third of the minority population is actually also the population living below poverty. And so that seems to suggest that there's still systemic racism, active policies or practices that are keeping minority communities from moving to more desirable places that happen to be cooler, more shaded, and have more protection against urban heat. And so it's also less wealthy white populations that are also being exposed disproportionately to heat. But then those patterns are actually quite different when you drill down into particular cities. So that was something we also found really interesting that we could do with the satellite remote sensing data. We could actually look at individual city exposure patterns vary populations. So this is actually my hometown of Greenville, South Carolina. So my parents are aged from Taiwan and they immigrated to the United States in the 70s to study. And then I was born in the United States here in Greenville, South Carolina. And so what we can see from this map is that the hottest areas in red happen to coincide with the highest percentage of Black populations and also those living below poverty. So you can see that blue dots and the dark purple dots happen to coincide with hottest areas of downtown Greenville, South Carolina. But then when we get more, it's actually quite different. Areas, again, tend to be those in the downtown urban area in the darkest red, but the Black population is a lot more dispersed. They're not all concentrated in the hottest areas. And then even the population below poverty, it's more intense. You see some pockets in the downtown area, but it's also quite dispersed. So those patterns are quite different. And so that can lead cities to think about how to target policy interventions and resources differently based on who's living in these areas that happen to be the hottest. And then, of course, you can see that the greenest census tracts, the greenest areas, also happen to be the coolest. And so that's quite interesting and I think very telling because I've spoken at a lot of different panels and seminars about urban heat and this research. And often I get the question of, well, what can policymakers and planners really do? And a lot of my co-panelists like to say, oh, just plant trees. But actually, I don't think that that singularly is to. And it's exactly because of this, these differences in the patterns of heat exposure and some of the co-benefits that might want to be considered by policymakers as they think about these different interventions and what's actually possible. So one thing that we learned in our community-facing work and working with local communities here and local governments in our NASA project is that a lot of communities and homeowners, for example, like don't actually want trees to be planted in the rights of way, which the city technically owns, because of perceptions in terms of maintenance. And if the tree grows to a certain height, and let's say there's a big storm and it blows over on their house, they may not want to have that particular tree because then that damage they would be responsible for that, even if the trees would be maintained by the city and it was located on public land. So that I think is one reason to think about and look at these underlying demographics and these different patterns of exposures in terms of trying to tailor solutions that's going to work. Our work also in this project more specifically and the policy that has left many cities is that yes, up there is much higher in so 87% ability of residents having proportionate exposure for below high communities of color versus those that are not communities of color. But equally surprising is that 91% of non-residents also have a likelihood of heat disparities. So again, that points to not just redlining as being the underlying cause and driver of modern day heat disparities. So this is also one of my, I think, pet peeves whenever I talk about this issue of heat disparities, because people say, oh, well, it's because of redlining. But what our data here shows that is not just because of redlining. Even in cities that were not redlined, also have a high likelihood of exposing populations disproportionately to heat exposure. So that seems to suggest that there is, again, actively something that's going on in terms of policy and planning that's exposing more vulnerable populations to higher levels of heat. And those patterns, unfortunately, are persisting across time. So I mentioned we can use that satellite data from the 1970s. In this case, we started from the 1990s, and we could get decadal averages of this land surface temperature to show that across time, even though some of the gap might be narrowing in heat exposure between populations living in A versus historically degraded areas, it's still today in the 2020s, even still, degraded neighborhoods are hotter than the A neighborhoods. And you would think that with tree planting and urban greening and renewal, that some of the greenness difference would be narrowing as well. And so these degraded areas through urban renewal, more parks and urban regeneration, that some of that would compensate for the difference in temperature. But we also see that there still is a persistent gap in greenness for these A versus D graded neighborhoods as well. And so in this conclusion here, you can see we see that 65% of cities have seen their land surface temperature gap between A and D actually widen. It's actually getting worse over time between 1990 and 2020. While 51% of these cities have also seen the greenness between A and D widen and it get worse for those D areas. So to me, this is a real policy and planning failure where even though there was this legacy and this policy of redlining that happened in the 40s and the 50s all throughout cities in America, we still are not doing enough to actually reduce those differences and narrow that gap in both temperature and also greenness that would cool these neighborhoods and make the differences much less and narrow that gap. So this is a paper, this is research that I'm finishing up right now. And so it's not yet published yet, so I'm sharing it with you, but would love some feedback on this study. So this is how we're using satellite data, and you can see some of the advantages of having this data. We can do these large-scale studies across the world, but then also focus in on U.S. cities, looking at cities all across the U.S., but then we can also drill down into particular neighborhoods within cities that we wouldn't be able to do if we just relied on weather station data alone, because it's very sparse and scattered throughout the world. But one of the things that we realized in doing this research, and our group, and along with TC, Dr. Chakraborty, we're really pioneering the use of remote sensing and evaluating heat island and temperature disparities. But what we also found is that it's not ideally the best proxy when we want to think about individual exposure that's most relevant for human health. And so this illustration here demonstrates some of the challenges of using this land surface temperature or the satellite derived measure of temperature. It's really measuring what is referred to in the scientific literature as skin temperature. So it's measuring the heat as it's bouncing off of your roof of your house or tops of trees or the asphalt and the tops of ground. But what the weather stations are measuring is more relevant for human health because it's measuring air temperature at around 2 meters or so. And so ideally, you could have more individual level temperature because I don't know about you, but I don't live on the ground, or I'm not always right next to the asphalt and living on the tops of my roof. And so it's really the air temperature from weather stations that really can help us get the more precise measure of individual heat exposure. And just to give you an illustration of when we compare these different data sources to measure disparities, what that actually looks like. So this is a map of Philadelphia. And then on the right in panel A, you can see this is measured by satellites, the land surface temperature. And it looks much worse. The disparities look much worse. You have temperatures in red, 45 degrees Celsius. And then in the cool areas in blue green, they go as low as 28 or 29 degrees Celsius. But then when we use an alternate measure, so this is mean radiant temperature, this is developed through using weather station data, but then modeled using an urban microclimate model. You can see that the differences actually are not as extreme. We don't see any of those red areas. So even though there still are differences, they're not as extreme as when we use the land surface temperature data. So you may see in the media and a lot of websites now, everybody's using the satellite data. And I think the New York Times and we have the NPR, National Public Radio, they developed a lot of maps not too long ago using satellite data. And they were saying, oh, these temperatures in cities across the US are over 50 degrees Celsius. And they were using land surface temperature, which is not wrong, but that's not the most relevant metric for human health and for how humans are experiencing heat in an urban setting. What's more relevant are measures like air temperature and then mean radiant temperature, which is an input into thermal comfort or heat stress indices like the UTCI, the Universal Thermal Comfort Index. And so to get at this data on the right, this B, what we have been doing is engaging citizens and communities to help us collect more high spatial and high temporal resolution data that we can get from low cost sensors, so from handheld sensors. And so a couple years ago, you can tell it's still during the pandemic because everyone's wearing a mask outdoors. We partnered with Durham City and County and also with the town of Chapel Hill to identify some of the hottest neighborhoods. So you can see that on the left. These are maps of different neighborhoods all around Chapel Hill that the town of Chapel Hill said these are the most vulnerable in terms of heat exposure and the urban heat island effect. And so it'd be really great if you targeted those neighborhoods to do this high resolution heat mapping. Then I sent out my students. So you can see a couple of my students in this middle panel, and they're holding this little blue square. So it's this little sensor that you can set it to a variety of different intervals. I think for us, we were gathering data every 2 minutes or so. And then we had volunteers, primarily my students. So I bribed them with a lot of extra credit. And so they had to walk these 1 to 2 mile paths in blue here and collect this kind of data. And this is what the data look like in the end. So you can see the routes that the students walked, and we had other volunteers. So we did ask for volunteers in the community. And Franklin Street, where the university is this neighborhood. I don't know if you can see my cursor, but it's this neighborhood over here. And what's really striking to me is that we were measuring temperatures with the handheld sensors between 94 degrees Fahrenheit. Sorry, I don't know off the top of my head what that is in Celsius, but then we also had temperatures as high as 108 degrees Fahrenheit. So just to give you a frame of reference, so this was very late in April. It was, or sorry, August. It was August 28th. I remember because, yeah, August is the end of August, and it was an incredibly hot day. My phone and the weather station said that the average temperature, the high temp, was only around 94 degrees Fahrenheit. And yet our students were picking up measurements as high as 108 degrees. And you can see that it's quite variable across the different neighborhoods. So this neighborhood here, much cooler on average than downtown Franklin Street. This neighborhood here, also quite hot. This is a huge shopping center in this area. And then up here, this is quite residential, but there is also a shopping center a little bit cooler. So huge differences, even within a very small area like Chapel Hill, you can have huge ranges and differences in terms of temperature exposure. So, of course, like having these 5 neighborhoods mapped is good, but we really want to know across the entire urban extent of Chapel Hill would temperatures be like that people would experience on a hot day like this August 28th in 2021. And so we can use machine learning, and in particular, use other satellite-derived and geospatial, and here this is an aerial image of Chapel Hill. So we could combine these different data sources along with this air temperature and humidity data that we collected through these handheld sensors by citizens, and then develop these high-resolution maps of heat stress. So that's exactly what we did, and you can see the result of the maps. So the A panels combine both, well, actually that would be C. The C panels combine both humidity and temperature data, but then you can see in A and B what we can do for just using that transect data from the individual citizens and students. We could then train a machine learning model to predict air temperature and humidity, and then ultimately heat stress all across the entire area. So this is then a lot more useful than having a single data point from a weather station or just having those measurements from the students in those various neighborhoods. Then we could present to the town of Chapel Hill and say, now you have a continuous map everywhere, every pixel, every space in Chapel Hill, you can have a map of heat stress, and then tie that to socioeconomic data to then ask those questions about disproportionate exposure to temperature, relative humidity, and heat stress. So that's some of the work that we've done. And I want to talk about that was characterizing the present, but then what we've been doing also for the present, but also for the future, and some of those other questions that we mentioned. So last summer, we continued some of this heat stress mapping exercise in Durham, North Carolina. And instead of just having citizens take sensors out for a day, we installed these low-cost sensors you can see in orange, and this is the radiation shield, all throughout the city of Durham. So you can see on the right, we use the satellite data to develop different deciles of heat exposure to make sure that we could have a representative coverage of temperature and humidity all throughout Durham. And we also wanted to include different land cover types, so vegetated and impervious surfaces, shaded versus non-shaded, because of course in our citizen study, they were all going along sidewalks or roadways that were unshaded predominantly and that were impervious surface. So we wanted to get a mix of land cover types. So we worked with the city of Durham and also a utility company, Duke Energy, that owned a lot of utility poles throughout the city of Durham. We got their permission to install these sensors and monitor temperatures and relative humidity for the entire summer, which was great. We only had 6 sensors that were stolen, so that's actually good. We out of 40 sensors, we only had 6 that were stolen. We did replace them when they were stolen, but overall, it was a really good exercise. And then we could try to replicate some of the same analysis with machine learning and having the satellite remote sensing data also combined with the data that we got from the sensors to then develop this below map of gridded air temperature to get some of that same coverage of air temperature and also heat stress throughout the city of Durham. So it was quite interesting. I think one of the most interesting findings from the study is in this next figure. So what we found is that in terms of shaded and non-shaded areas, you would think that shaded areas would overall, again, tree cover being the singular most popular policy recommendation for what governments can do about urban heat. But actually, we found that there were some trade-offs, and we could only find that with our continuous low-cost sensor study, where you can see in blue, the non-shaded areas, yes, they happen to have the highest temperatures throughout the day here at the peak, but then they quickly cool off. And so then at around, here we have 6 o'clock and then 8 o'clock here, they start to cool down much more rapidly than the green shaded area. So this is an example of a shaded area. This is a fisheye lens of a shaded area, because actually the tree canopy traps some of that heat that would have been released if it were not shaded, and actually allow for that area to cool down. So this to me was quite surprising, because even in my own home where I am now, we have a lot of trees that shade the roof of our house. And so what this data seems to suggest is actually we might have to increase our cooling, particularly during a very hot summer night, to compensate for the fact that the tree canopy is actually trapping some of that heat that doesn't escape out into the air. So that was something that was quite surprising. This is also very new research and data that we are currently putting into a publication that hopefully will be published soon. So what are we doing also with that data? Well, we are using it to get more high resolution measures of mean radiant temperature that ultimately will feed into this UTCI, or this universal thermal comfort index, which is much more relevant to understand heat stress of the body and the human experience of urban heat that is not just air temperature alone, or God forbid, the land surface temperature. And so you can see that with this urban microclimate model that we're working on now as part of our NASA project, you can even see the outline of buildings and roadways and also the shade cast by certain buildings compared to this land surface temperature. So this is from the satellites. It's just a very murky picture. And so let me give you a look at what that looks like. So this is Durham. Again, you can see that big red Durham freeway that intersects the city and has left this area much hotter. Here, this was that historically Black community. And we're able to get 1 meter resolution. So you can see this is from our data and the train model. This is the Hayti neighborhood right here that is really, really dark. So in mean radiant temperature, so that's the combination of heat and radiation coming from the asphalt, from different buildings, the entire urban context that then goes into this urban thermal comfort index. And so the video is looping again, but you can see that it gets incredibly hot here. And um, here, this is also from a paper that we published, and our collaborator who has developed this technique and method is Xiaofang Li, who is at University of Pennsylvania. And you can see that buildings too in this video cast a lot of shade that can actually cool an urban area. So the cooler areas are actually in purple, the hotter areas are in orange and yellow. And so actually that's another potential policy intervention that is not often thought about as cooling urban areas. So they actually call that gray shade, or instead of like green shade, which is coming from trees. And so that's also another relevant consideration that is often left out of the conversation, where buildings could actually help to provide some shade during different times of the day. So one of the projects that my PhD student is working on now is with the city of Raleigh. After the heat mapping exercise, they saw where the hottest areas were in the city of Raleigh. They actually moved in their city council to allocate a budget of $77,000 to then coat some of the hottest roadways with a reflective titanium dioxide coating that would make them much more reflective and cool those areas down instantaneously. So again, that's why I say that tree planting is not always the number one solution, because you have to, first of all, get the buy-in of people who might be living next to those trees. And then secondly, it takes time for trees to actually grow to maturity and then develop a canopy that can have cooling benefits. Whereas if you then coat a pavement with this reflective material, you get those benefits instantaneously. And that's exactly what she's doing now. She put out our sensors again this past summer in all throughout Raleigh and around these different cool pavements. And now she's just waiting for the Raleigh Department of Transportation to coat these roadways with a cool coating. And then she can design, is basically an experiment to then understand how much these cool pavement interventions could actually reduce temperature. And they also have been known to improve air quality as well by absorbing some of the air pollutants that are surrounding these areas as well. So the last part, and I promise I'm almost done, so is again this future projections. And so this is a paper, we have a preprint available on our website, but it's hopefully in the last rounds of peer review, and we'll be able to share these results more widely then. But we're looking at these IPCC climate projection scenarios. So that's what these symbols and these numbers mean on the right. So you've got SSP, that's a low warming scenario, all the way to SSP 5, RCP 8.5, which is a high warming scenario that's generally thinking about 4.5 to 5 degrees Celsius over pre-industrial levels by 2100. So we can use these projections to understand how temperatures might affect different populations throughout the United States. And yeah, it's a pretty grim outlook. And so even in the low emission scenario, approximately half of US counties are projected to face heat-related health risk by mid-century. And then under the high emission scenario, so the worst case scenario, only 8% of the counties will be in a safe zone. So really, this is an issue you can see very much by the end of the century, so 2100 or so, that most of the US is going to be facing a situation if global warming follows this particular trajectory. And so most of the counties, so only 8% of the counties will not be at risk of dangerous heat exposure. So that's very alarming. And then in terms of disparities, also these different scenarios, we're able to understand how disparities might change for different populations. And then what we found in all of these different scenarios is that non-Hispanic Black populations will experience approximately a 3-degree Fahrenheit higher average temperature compared to non-Hispanic white populations. And then not only does the absolute disparity, as I mentioned, increase for non-Hispanic Black populations, but the relative disparity, so that's the disparity between groups, different racial and ethnic groups, tends to decrease because heat index increases ubiquitously. So it gets bad for everyone, as we saw in these previous maps. It's bad for everyone. And so the relative disparity decreases, but then the absolute disparity increases. You can see for these different years, the absolute disparity increases for Black Hispanic populations, for non-Hispanic Black populations in all of these different scenarios. And then for age as well. So elderly people age 65 or older on average, they currently experience lower heat index than the adult population. But then in the future, there's going to be a disproportionate increase for heat index for elderly populations age 65 and higher, even though these disparities are not as stark as the disparities between white populations and non-Hispanic Black populations. So also, not only is it bad right now, but we can see that with these future climate scenarios, there is definitely some not so great news for both age groups and elderly populations, and also for minority populations that stand to be at a greater disparity of heat exposure and related health effects. And so I just want to end with just some conversation about where we're taking some of this work in the future. I have a PhD student who is trying to think about resilience. So everything that we've been doing so far is characterizing urban heat risk, but also what we have found is that cities, they want to know what assets they have or what adaptive capacity they have to actually mitigate and lower their risk to heat exposure and to reduce the vulnerability of their populations to extreme heat events that are becoming much more frequent and much more common year after year. And so that's what one thing that we're doing now is to try to think about how to actually quantify it, even on a neighborhood scale for our urban environment and social inclusion index, how we can think about the hazard on one hand, and then what assets communities might have to then mitigate that particular hazard and to reduce the exposure for vulnerable populations. I also have a PhD student who's working on trying to understand the health linkage. And so she's working with the Environmental Protection Agency to then use some of our high resolution data, connect that with heat mortality and heat related health effects data to really understand when you have this higher resolution data, how much more precise does that get our health related impact measures? And then she's also using some of this data to understand the effectiveness of heat alerts to try to bolster community resilience against extreme heat events. And then I'm also interested in green gentrification and some of the more social dynamics that are underlying the present day persistent disparities in both greenness and tree cover and heat exposure for minority and low income populations. And so through urban renewal, which is still happening in cities all across the United States, what sometimes happens is as neighborhoods become more green, that raises the property values and the home prices, forcing low income and minority populations that were meant to benefit through these urban renewable and regentrification policies. And then that pushes them out. And so it's this kind of green gentrification that is happening as planners and policymakers are actually actively trying to cool these neighborhoods that are historically redlined. It's a very complicated data question. So if anyone has any ideas, I'm definitely open to suggestions because we've been finding it very difficult to actually use statistical modeling or regression modeling, for example, to try to isolate some of these causal factors. So I know I'm a little bit over time, but I hope we have plenty of time for questions. I just want to thank everyone on my team and collaborators that have contributed to this project. So thank you very much, and I'm looking forward to your questions.
Thank you very much, Professor Xu, for the rich and thought-provoking presentation. And actually, there is no shadow on the roof of my house, and I feel very hot inside every day. So, okay, before we open the floor for the questions, I would like to invite Professor Jiro Mizushima to offer his comments as a discussant. Hi, yes, Professor Mizushima, please go ahead.
Uh, Thank you very much for your presentation, Professor Xu. You pointed out quite convincingly that climate impacts are felt disproportionately in urban communities. The most vulnerable ethnic minorities are hit most severely by heat island effect. And it is really a shocking fact, and it's alarming that even within a small area, there is a great difference of temperature. This problem should be tackled as soon as possible, I think. I have two small questions. My first question is about the concentration of population in cities. Everywhere in the world, we see a continuous inflow of people to the urban metropolitan areas from countryside and from abroad. Especially younger generations like to go to large cities, and that makes cities more populated, hotter, uncomfortable space. Still, they prefer to go to large cities. This is probably, I think, because they think that cities can offer young people more jobs, well-paid jobs, more social chances, more possibility, in short, better lives. Even it is quite hard in cities, and even if you live only in a small room, for younger generations, it's not the point. As a result, areas with more ethnic minorities, populated areas, would attract more people from outside. This irresistible attractiveness of cities would make the problem of heat island more complicated. What do you think is the solution? If you would prevent the concentration of people in metropolitan area, you should have a well-designed urban planning policy or special planning. But it's not an easy problem, I think. My second question is about the gentrification. Large-scale gentrification in the central urban area would produce more green spaces, more trees, more parks, more modern tall buildings, and luxurious condominium. If you think about the problem of heat island, gentrification itself would be one solution, because in the process of gentrification, old, densely populated poor areas would be changed dramatically or disappeared totally. However, I think that kind of gentrification might destroy the community, day-to-day social relationships within that area. Densely populated urban areas could be a rich source of social capital and popular culture. In short, community assets. That kind of community assets is also important to tackle the urban problems. It is also a quite complicated problem. But anyway, probably we have to find a balanced solution about the heat island effect. Thank you very much.
Thank you. Is it okay if I respond to Professor Mizushima?
Yes.
Okay. I mean, two wonderful questions, and I think you really hit the nail on the head. In terms of cities being centers of attraction and economic opportunity, I think you're absolutely right. And so we know that looking at all of the future urbanization trends, that more people are going to live in cities, 68% by 2050, 75% by 2075. I mean, it's just going to continue to increase. And so I think you're absolutely right. How can we make cities cool and livable and fair and centers of justice? Because inequality is increasing in cities all across the world. I mean, in the United States, you really feel it. And New York City is just, I think, iconic. And everyone always wants to move to New York. And it's just so vibrant. But it's also one of the most unequal cities in the world. And so there has been a very central tenet of climate justice, which is there cannot be climate justice without racial justice or economic justice. I think that's very clear in the literature and a lot of the thinking about climate justice and how to actually achieve climate justice. And so it's very intersectional in these different dimensions. And so I think that what we're trying to do with our data is to, as you said, shed light on these disparities and use data to actually identify, well, how are different populations affected? Who is affected? And who are they? Who are the populations that are being affected? Because the idea is then cities and policymakers and planners can hopefully then try to direct resources and particular interventions to then try to ameliorate some of these differences. And I think that was the goal of SDG 11. They had this inclusion dimension alongside the social, environmental, and economic indicators for cities. But of course, they didn't provide the spatially explicit data. And so that's really what we're trying to do. And I think that we have to really think smartly about how to design cities in a way that can be cool. And as you said, also have parks and green spaces where people can leisure and convene and also promote social cohesion. And it's not easy. As you said, it's very challenging because, of course, when urbanization and industrialization began in many parts of the world, cities were considered actually sites of pollution and sites of blight, as that one poster showed in Durham. And so I like to look towards Singapore because I lived there for 6 years. And I think that that's one really great example of where, with a very small area of land, they've tried to maximize the amount of tree cover and canopy. They have zoning laws, so then any tree cover or green space that's removed, they have to replace. So they have a lot of sky gardens and vertical vegetation. They have rooftop areas to try to replace some of that lost greenery. And they have really tried to develop this garden city concept. I mean, this is what Lee Kuan Yew, when he founded Singapore, really tried to foster. But I mean, I think in a lot of parts of the world, they can't replicate the Singapore model. You know, I always, when I lived there, I was like, this is great, but really, how replicable is it, especially for cities that are already established and they can't exactly go about and retrofit and develop totally new urban forms? And I think what we're seeing, particularly in Europe, is that they're having to adapt to rising temperatures and more frequent and prolonged heat waves through air conditioning. And then that can actually make cities less livable because of the additional energy consumption and the additional heat actually generated through air conditioning. So I think there's a lot of these kinds of tensions. And that's one of the reasons why I think your second question illustrates exactly some of the trade-offs. Like when you think about greening policies or how to solve the housing crisis or to develop more green spaces, this is exactly some of the dynamics of green gentrification. You're making these areas more desirable, and so that's pushing up land prices. And then wealthier populations are able to move in, and then these less wealthy populations or minorities are getting pushed out. And so these are very complicated dynamics. I totally agree. We have to think about a balanced solution. And I really like your idea of social capital. I was like thinking about our framework. And so a question for you and others on the call is, how do you think we could measure social capital, or what are the key indicators and metrics of social capital that we should be thinking about as an indicator in our resilience framework? So if you have any thoughts on that, on what do we mean by, how do we define social capital and measure it, I would love to hear your ideas.
I think we have to strengthen our international and interdisciplinary collaboration between to tackle these kinds of problems. You have to combine the ideas of many disciplines, including social sciences and humanities, I think. Thank you very much.
Yeah, I agree. I agree.
Okay. Thank you very much, Professor Mizushima and Professor Xu. And we would now like to move on to the Q&A session. If you have any questions or comments, please feel free to write them in the chat or raise your hand. Okay, Professor Kawase, please go ahead.
Thank you very much. Do you hear me okay?
Yes, I hear you great.
So thank you very much, Professor Xu, for your very exciting and energetic lecture. I am Takayuki Kawase from Chiba University, and my major is philosophy of law. And I'm interested in the topics such as interaction between the different kind of fields, such as interaction between law and politics, and interaction between science and religion, or interaction between ethics and art, or such kind of thing. So, and I have a question to you from such kind of perspective. And before starting this session, you mentioned the relationship between American federal government and scientific research. So in my opinion, I think the politics and the natural science are deeply interdependent and almost inseparable. And my question is, how much do you think the science, the natural science, can be or should be independent from the politics? So that's my question. And one more small remark about the heat island phenomena. From your lecture, I really understood the importance of the green park in the city center. So, such as Central Park in New York City or Imperial Palace in Tokyo. And I think Tokyo is a kind of good city because of such kind of very big park or greens in the very center of the city. But Tokyo is still very hotter than Chiba, such as the suburb area. But this is just a comment. So my question is the relationship between the politics and natural science. If you have any ideas, please tell me. That's all. Thank you very much.
No, thank you for that very rich question. And when you said that you study philosophy, I was preparing myself because I was thinking you would ask a very deep and profound and challenging question. So it's very good. Yeah, I mean, this is not quite really what I study, but I have thought about it a lot just because you realize how politicized science is in the US context. So I am American born, but I have spent a lot of time in Asia, particularly in China. And I worked on my dissertation with collaboration with the Chinese government and with Chinese universities. And what I realized is that a scientific issue like climate change is really not politicized. They approach it from a very scientific perspective where it doesn't matter if you're talking to a taxi driver or a business person or a politician, they all believe in the fundamental science and the fact that climate change is real and that it is driven by anthropogenic or human forces. That's irrefutable. All the scientists in the IPCC were all 100% on the same page that climate change is happening. But in the US, it's a political fact. It's a political idea and phenomenon. And I find that that's really challenging to reconcile because I have debates on a daily basis here in America of people trying to tell me all the time that climate change is not real. And it's become part of the culture war. It really has in the United States. And so if you say that you believe climate change is real, people affiliate you with a political ideology and with a political party, and it's become bipartisan. And that's really unfortunate because, I teach climate politics and policy in my climate change class to undergraduate students. And we talk about the history of climate policy in the United States. And it wasn't always bifurcated along partisan lines. It was not a bipartisan issue. The Republicans actually believed in policies to tackle climate change, and they were some of the early leaders on sustainability and attending the 1992 Rio Earth Summit and sounding the alarm on sustainable development. So I think it's just really unfortunate that it has become very politicized in the United States because now it's a cultural identity issue as opposed to a scientific issue that we as a society need to work together to tackle. And much of my research is exactly on that. It's how we need to have all a society approach to tackle climate change. It can't just be national governments or city governments or individuals or NGOs. It has to be everybody doing their part. And so, yeah, I think and we can see that it's really led to a lot of political inaction on climate change in the US context, where you have a change in presidential leadership and all of a sudden the United States is out of the Paris Agreement. We've essentially dismantled most of the federal organizations and institutions that were collecting climate change data. So a lot of the data that I showed you, I don't know if it's going to be around in the next 5 or 10 years because the satellites are being maintained by NASA, and then the politics are coming through and gutting 56% of the Earth science budget that is funding my research. So it's going to have very devastating effects. And I mean, I think that what we also have seen in the United States in the past 8 months is that the two are very intertwined. The natural sciences depend very much on the politics and the national government because so much of it is funding, so much of the national government is funding scientific research. And it cannot happen. And all of the philanthropies and the foundations have said we cannot make up for the shortfall in federal support. So they're very intertwined and dependent. It's an interdependency how we've fostered science and scientific research in the United States. But because of that interdependency, it's become also politicized. And we can see how tenuous it is when the United States government pulls back the support. I mean, now scientists are leaving the United States. I mean, yeah, is Chiba University hiring? Because maybe I want to come and work there because it is really challenging, and it's really hard. It's hard to continue to research these topics. I teach on these topics in a university setting that is frankly under attack. So it's my personal belief is that we need the governments to be on the same page and to support research because it's so critical to everyone's safety and to economic success, to protecting against climate change. But yeah, when it's become politicized in the opposite way, you can see that it becomes then very threatened and yeah, very uncertain.
Thank you very much. I think, yes, the funding is very serious and important key issue, I think. And it is same in Japan as well. So I think Japanese situation of the natural science is not as politicized as American, but anyway, I think the basic structure is the same. And actually, I have another or the same question as you to Professor Mizushima about the how to measure the social capital. And I am a philosopher and I am not very good at dealing with data or evidence. So that's not my business. So, but I think, how to measure or how to define. So definition is my business. So how to define or how to measure social capital is a very, very important issue for this research, not only for the climate change issue, but also the our topic, the fairness.
Yes.
So,
yeah, I completely agree. I mean, it would be great to have my PhD student weigh in on this. So we're having actually a mini workshop in our lab on Monday to try to flesh out and get some feedback to how we're thinking. I'm going to bring up the issue of social capital because she has looked at some things like, is there a community center that's available in a neighborhood, right? Like, or what's the distance to a community center? I mean, we don't really have that many of those where I live, but I was thinking in Singapore, almost every housing development block. So in Singapore, they have the HDBs, and then there would be these community centers in every neighborhood. Like I could actually tell you where the community center was in my neighborhood in Singapore. I can't tell you here, like in the US, but I can tell you in Singapore. And it is like quite remarkable because during the COVID-19 pandemic, I was living in Singapore. They would be the first ones to provide masks or information about like vaccines or like social distancing, right? And that's really important to protect public health. So I think that the presence of a community center, and I guess in the United States, the analogy would be churches and religious organizations, particularly in the South. So maybe something along those lines. But yeah, I think that's a really interesting question that I'm definitely going to bring up to my PhD student because we're having this conversation on Monday. Yeah.
I guess Professor Kobayashi from our group, he is absent today, but actually he must have some answers about that. So he is a communitarian. So he researched the communitarianism in Japan and maybe in America as well. Yes, he is those who introduced the theory of Michael Sandel to Japan. So actually, yeah, he has a lot of thing about the social capital index in theory. And I believe there are many researches about social capital in America as well. But
Yeah, no, that's great. Yeah. Perhaps you could introduce me over email to Professor Kobayashi after, because yeah, that would be great to learn more about his work. And yeah, I'll look into the social capital index. That's a really good suggestion.
Thank you. That's all from me. Thank you very much.
Thank you.
Professor Kawase, thank you for your questions. And we still have time for maybe one questions. Does anyone have any questions? Dr. Alphonse, can you hear me? Do you have any questions from Mexico? Oh, maybe Dr. Alfonso is not here.
Oh, I'm here, sorry.
Yes, do
Oh,
you have any questions from Mexico?
I am thinking about many things related to climate change and the effects. I mean, I am not an expert, so I am still thinking.
Yeah,
Yes.
no worries. Thanks for joining from Mexico. Where in Mexico are you based?
I'm in Mexico City.
Oh, wonderful. Mexico City is such a beautiful city, but also very big and sprawling and probably has a lot of urban heat island issues.
Yes, of course. And as you say, it is obvious that the poorest towns are the ones with the worst
Yes.
heating problems. Yes.
Yeah, Mexico City is in our urban environment. Yeah, actually, I can include in the chat the actual link because I just noted we just updated the website this year, and I haven't updated the link everywhere. But yeah, this is the link to our Urban Environment and Social Inclusion Index. So yeah, we have Mexico City in there. We may have some other cities in Mexico. We did have Monterrey in Mexico, who was also very interested in this index. And so a few years ago, we had a nice exchange with their sustainability officer. And yeah, they were also talking about climate change being a top concern for them as well. And yeah, so but also like they said, inequality also very big problem. And so how do they like balance economic development and lifting people out of poverty while making sure that they're not being unduly exposed to, yeah, climate impacts and urban heat island and things like that. So we had some really interesting exchange with them.
Thank you. That's very interesting. I mean, um, I need to think about something,
Yeah, feel free
some
to
other
email.
ideas.
Yeah.
Yeah,
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 I
yeah.
shared
I
the
will.
slides, yeah, with Dr. Zhang, so she can share those with whoever would like to follow up or study the slides in more detail. And then my email is also, I can leave it in the chat, but it's also in the slides. Or you can Google me. I'm also like very Googleable.
Thank you very much. Yes. Okay.
Thank you.
Thank you, Professor. Sure. Yes, I also find your information from the Google.
Oh, great.
Yes, and now we still have 2 minutes. Does anyone have any questions? Professor Ishito, do you have any questions?
Okay. Hello.
Hi.
You hear me okay?
Yes.
All right. So my name is Hikari Ishida. I'm professor of international economics, and I fully enjoyed your presentation. So thank you very much. We only have a few minutes, and so I just want to share this link with you. One of my college classmates, his name is
Oh,
Taishi Sugiyama. He used to serve as one of the lead authors of the IPCC report, I hear. So if I don't know if you know him, I mean, Mr. Taishi Sugiyama. But anyway, he is mentioning, okay, this kind of thing. Extreme heat is not due to global warming, and so yeah, I mean, extreme heat is most of the parties, part of like a natural, like cyclical thing, and also in the urban part of the climate change is definitely caused by what is this heat island impact that you talked about. So maybe if you could just link up to people like Mr. Taishi Sugiyama, then you will fully enjoy your time here in Japan, because he used to serve as this the IPCC report lead author, and still somewhat against this this what is it overall what is this climate, or people talking about climate change and not talking about other factors. So maybe you can link up to him and then talk to
Okay.
yeah.
Yeah, I have to read this article. I mean, I think sometimes I don't know what media this is, but sometimes the media likes to, I don't know, put very like eye-catching headlines, but then it may not reflect the actual content. I mean, I will say that extreme event attribution, and so that's probably what he's talking about. It's a lot more complicated than just saying, oh, it's a one-to-one, right? Where you have global warming, and then that automatically leads to more extreme events. So my colleague in our statistics department, he actually does a lot of this extreme event attribution and detection and attribution, which is a big part of the IPCC. And yeah, I will say that even between AR5 and AR6, there's more evidence to suggest that there is a connection between global warming and like maybe not the frequency, but certainly the intensity and how prolonged these extreme events are. But yeah, I mean, in terms of hurricanes, and then also, yeah, like extreme heat events. I think probably for extreme heat more so than hurricanes and other types of natural disasters, there is more of a connection where when you have higher temperatures, then you get like these heat domes, right? Because you also get less precipitation. And so it's also these other indicators that allow for conditions to then result in these more prolonged and more intense events. So I haven't read this, but yeah, I mean, I definitely think that the science and the evidence and the models are really converging to suggest that global warming is indeed leading to at least more prolonged and more intense, and in some cases more frequent events. I think heat waves are actually certainly one of those where the evidence is most clear that there is a relationship. So I'd be interested in reading this. I'll look up his work after this seminar.
Thank you so much.
Thank you so much, Professor Ishido and Professor Shu. I'm sorry for overtime. And
no,
now,
it's okay. I mean, I'm not going anywhere, so, so it was
thank
really
you very
nice
much. Now it
yeah.
is end time. And once again, we sincerely thank you, Professor Andrew Shu, for her excellent presentation and Professor Mizushima for his thoughtful discussions. And of course, thank you to everyone who participated in today's seminar. And we hope to see you again at our future events. And for Professor Shu, I hope I can see you at Japan, Chiba next year. Yes. I'm looking
That
forward
would
to
be
see you.
great.
Yes.
Yeah, I would love to come back. Yeah, I'll let you know if I'm in China because then that's like much closer to Japan. So I'm planning on going to China. So definitely let you know my timing.
Okay, looking forward to see you
Yeah, great.
at
Okay,
Japan in the
wonderful.
future. Yes.
Yeah, that would be awesome. I would love to meet you in person.
Thank you very much for this. Thank you very
Okay,
much.
thank you. Thank you. Hope you have a
Bye-bye.
great day.
Thank
Thank
you.
Bye-bye.
you.
Bye.
Okay, bye.
I see you.